Hello, we're going to talk about solutions in this video, and I'd like you to put these notes on page 81 of your ISN. We're going to talk about what solutions are and how solutions are formed. So a solution is a homogeneous mixture consisting of solutes dissolved in a solvent. So it's a homogeneous mixture. Remember, that means that all of the different particles in the mixture are evenly distributed. Gases, liquids, solids can all exist as solutions. So air is a solution of gases, so a homogeneous mixture of gases. The Coke that you might drink is a homogeneous mixture of gases and liquid. So the carbon dioxide is the gas. And then several alloys like brass is an example of a homogeneous mixture of solids. So it consists of a solute dissolved in a solvent. So what is a solute and what is a solvent? Well, the substance that is doing the dissolving, or the substance that is present in the largest amount, we call the solvent. So in chemistry, our solvent is usually going to be water. The solute is the substance that is being dissolved. Okay, so for example, if you're making a solution of salt and water, the salt is the solute and water is the solvent. As I said, in chemistry, we're typically going to deal with water as our solvent, and we call solutions in which water is the solvent aqueous solutions. And you'll actually see this abbreviated in the next slide as AQ. So aqueous just means that water is the solvent in the solution. So how do solutes dissolve in a solvent? Well, this process is actually called solvation. Okay, so solvation is the process of dissolving in which positive and negative sides of a solid become surrounded by your solvent molecules. So in the picture here, I have sodium chloride. So we have an ionic solid at the bottom. I can tell it's an ionic solid because I've got a positive cation and a negative anion. And this is just like what you did in the lab on Friday with your water kit, but you showed how water can surround each of the separate ions. So when you put a solid, an ionic solid, into water, the ionic solid will be pulled into its different ions. So let me show you an equation that represents this. So when we put an ionic solid such as NaCl into water, it will get pulled into its separate ions. So notice how we've got Na plus, and Aq means it's dissolved in water, Cl minus, Aq meaning it's dissolved in water. And just like you modeled in the lab, the chloride ions become surrounded by water, but they're surrounded by the positive hydrogen end of water. The positive sodium ions become surrounded by water, but they're attracted to the negative oxygen side. And I'm going to show you an animation of this happening. So let's look at the solvation of an ionic compound in water. Dissolution is another term that you might also see to mean the same thing. So we're sprinkling some of our NaCl table salt into the water. If you stir it up, that helps it dissolve a little faster. And then we're going to zoom in and look at what's happening at the microscopic level. So notice we have our solid sodium chloride. Okay, so it's made up of a repeating pattern of positive, negative, positive, negative. And what I want you to notice is what's happening to the water. So at the surface of our ionic solid, the water molecules are breaking the solid apart into the individual ions. And notice how when we have a negative ion pulled apart, it's being surrounded by the positive side of the water, the hydrogen atoms, and the positive ion was being surrounded by the oxygen side. So let's go ahead and watch it one more time. So pay attention to which sides of the water molecules are attracted to each of the different ions in our compound. Again, notice this is the negative ion. It's surrounded by the hydrogen, which is positive. Our positive is surrounded by the oxygen, which is negative. So that is essentially how ionic solids dissolve in water. So water essentially surrounds and pulls the individual ions, the cation and the anion, apart. And of course, the hydrogen part of water is always attracted to the negative, the anion in the ionic compound, and the oxygen side of water, because it's slightly negative, is attracted to the cation. So when we're trying to figure out if a solute will dissolve in a given solvent, we need to know what type of molecules we're dealing with. In other words, we need to know whether or not our solute and solvent are polar, nonpolar, or ionic. Chemists like to use the phrase like dissolves like, so we're going to talk about what that means on this slide. So the type of molecule and the intermolecular forces that form will help us determine if solvation will occur. Like molecules will hang out with each other to form a solution. What that means is that a polar molecule will dissolve in a polar solution, okay? Much like you observed in your lab on Friday. So typically when we have a solute and a solvent that are alike in terms of the intermolecular forces they're experiencing, they will form a solution, a homogeneous mixture. So for example, here we have a picture that is showing water as our solvent, and we know water is polar, and really anything that's polar or ionic will dissolve in water. So like dissolves like. Basically anything that has a charge will dissolve in a solvent that has a charge. Now molecules that are not alike, so in other words, if you have a non-polar substance, it would not dissolve in water, right? And we saw this in the lab on Friday. Ethane did not dissolve in water. So let me show you these water molecules again. So these are the water molecules that you guys played with on Friday. So sodium chloride did dissolve, right? So here's my chloride ion, and it was able to be surrounded by the positive side of the water, the hydrogen, right? And I can completely surround it here. So technically this chloride ion is dissolved, okay? Your sodium ion that was positive was able to be surrounded by water because the positively charged sodium was attracted to the negatively charged part of the water. You also had methane in your kits. Okay, so this, or sorry, not methane, ethane. This was your ethane. And ethane is only made up of carbon and hydrogen, so it's nonpolar. And you should have noticed that there was no attraction between the water molecules and the ethane molecules. So ethane, being nonpolar, would not dissolve in water. So like dissolves like. In other words, polar substances will dissolve in polar solvents. If you have a nonpolar substance, it will not dissolve in a nonpolar substance. So I have a question for you. I want you to pause and think about it. But do you think sucrose will dissolve in water? So here's sucrose's formula. It's C12H22O11. I've got a picture of it here to show you that because of the oxygen, there are parts of sucrose that are polar. So I want you to answer the question, will sucrose dissolve in water? Keeping in mind that water is polar. So if you answered yes, you're correct. So because water is polar, the parts of the sucrose molecule that have a charge will be attracted to that opposite charge of the water molecules. Now there is a difference in what happens with sucrose, so polar covalent compounds, as compared to ionic solids. So sucrose and other polar covalent compounds, they will dissolve in water, but they're not made up of oppositely charged ions. So we don't see the compound separate into its individual components. Instead, the entire molecule, so you see here, gets surrounded by water. So it will dissolve in water, but we don't find that the individual atoms that make up the compound separate. And this is one of the reasons that ionic compounds, when they're dissolved in water, they conduct electricity because we have ions, charges moving in the solution, whereas for polar covalent we really don't, because they stay as a whole molecule that just gets surrounded by water. So there are a couple of ways that we can increase the rate at which things dissolve. So one of those ways is to change the surface area. You should have noticed in the animation that the dissolving process occurred at the surface of the sodium chloride. So if we increase the surface area, so the amount of surface area exposed to our solvent, we can speed up the rate of dissolving. Okay, so increasing the surface area is one way we can speed up the process of dissolving. Another way, we did this in the animation, is just to stir. So if you stir a solution, then you're going to allow the solvent and the solute to come into contact with each other faster. So then we get a higher rate of dissolving. The third way that we can increase the rate of dissolving is to increase the temperature. So when we increase the temperature of anything, we're really making the molecules go faster. So if they're moving more rapidly, then they're most likely to come into contact with each other more often, and then that increases the rate of dissolution or solvation. So those are three ways we can affect the rate of dissolving: changing the surface area, stirring our solution, and changing the temperature. So one last thing that I want you guys to keep in mind, and we'll talk more about this next block day in our lab, but the composition of our solution is very important. So we say that our solution is saturated when as much solute as possible is dissolved at any given temperature. Okay, so a saturated solution is one that contains as much, so the maximum amount of solute that it can. Okay, an unsaturated solution is one that does not contain as much solute as it can. Okay, and remember that temperature can change the amount of solute that can dissolve. We'll talk about this more on block day. So a saturated solution is a solution that contains the maximum amount of solute, that has the maximum amount of solute dissolved. An unsaturated solution is a solution in which we could still dissolve some more. Okay, now I don't know if you've ever made Kool-Aid or lemonade as a kid, and well, my kids really like sugar, so they want to keep adding sugar. So there is a maximum amount of solute that every solution can contain. When you reach that, when you go over that, we say you have a super saturated solution. So when I was a kid, or I'm sure if I had my kids make like lemonade, powdered lemonade, or Kool-Aid, they'd probably add too much sugar, right? And how we would know that it's super saturated is the sugar would no longer dissolve, it would start to settle at the bottom. So we would call that a super saturated solution because it would contain more solid than possible at that temperature. So you can tell when you have a super saturated solution because you'll start to see a solid form at the bottom. Now, thank you for watching the video. I hope that it was informative, and I'd like you to go ahead and start page 5 of your homework packet. We'll talk a little bit about it on Monday, so let me know if you have any questions.